Hi everyone, and welcome to our latest webinar. My name is Peter Sonnenschein, and I'm the head of sales of the distribution department at Lumitronix. And today's webinar, the title is Optimize Your Light, is all about optics and how you can optimize your light with using optics in indoor applications. So let me just give you the exact title. I'm truly happy that it's not only me speaking to you today, but to have our three valued partners, Lede, Gaggione, and Gaggione, today with me to present in this particular webinar. And we felt it was about time for a dedicated optics webinar. And I do believe it is a great chance for you who are attending the webinar to have three optics manufacturers being together presenting in one webinar. So this is the slide I wanted to show you. As you can see in the picture, we are not only a distributor for different optics and LED brands, but we also see ourselves as a specialist for developing and manufacturing light sources, and thus to offer an all-from-one source philosophy to our customers. To be able to do exactly that, we need the best possible partners to add the best possible values to our portfolios with LED modules, controllers, etc., etc. And optics is definitely a big part of that. The variety of possible indoor lighting applications is vast, lasting from warehouse lighting with heights of 5 meters or more, can be office lighting with UGR smaller than 19 requirements, can be emergency lighting, can be shop lighting to highlight a certain product, or it can be ambient lighting with color mixing options. All of these just mentioned examples need optics in order to reach for the perfect result. As I already said, here at Lumitronix, we are a specialist for developing light sources, and the usual way for us is to start with designing a light source and then choosing an optic to fit the light source. But we learned that the other way around, by starting with the optic and designing a light source fitting the optic, can be as effective. I'm sure in the upcoming presentation we will learn a lot about the lighting products, optics from each manufacturer, as well as seeing some good examples of fitting LED modules and optics.
A special thank you to all of the Lumitronix team. I mean, Alina, Paul, and Peter. Gaggione has been working quite distantly with Lumitronix for a couple of years, but I'm glad to say that we are now part of the official Lumitronix portfolio among optic products. So thank you for that, first of all, and thank you for inviting Gaggione to such a webinar, which I think is very valuable for everybody. So let's start. Topic I'm going to address today is to share with you some struggles we had in the past with color mixing, optics development, and especially on the qualification side of the performances, and how we sorted this out, and how this way we sorted out could possibly be a tool for you to select and pre-qualify some color mixing optics and LED combination. So topics for today are how to qualify the color mixing quality, which was our struggle in the beginning, and how to predict color consistency among your projects or your discussion with customers on color mixing based optics or solutions. Where did we start from? In the beginning, Gaggione has been involved into optical injection and optical system development since 1948 for the company age, and I would say since the 90s for the optical side of our business, which is now most of our turnover. And we always have been, in a way, specialized in both development fields, one being the narrow beam optics, the other one being the color mixing, where we had a lot of activity and still have a lot of activity opportunity in the entertainment business. And we see a clear trend from all this color mixing technology that was used first in the entertainment, then into the architectural application field, is now jumping into indoor office lighting and application. And our difficulty was to honestly address the quality of the color mixing of a given beam. And in the first place, it was mostly a research and development struggle for us to be able to fairly address the result in between different options, different injection parameters, or different designs. So we needed a tool to address the color mixing performances and to measure it in the fair way, which tool we didn't find. For what kind of application could such a tool be useful? Obviously, I mean, for any static white luminous, we know that some LEDs will produce some color defects like the color over angle, meaning the color temperature not being consistent among the emitting angles of the LED. So even the white luminous can find some interest, and the white related developments in general can find some interest in being able to address the color consistency of a beam. It's of course very relevant for any human-centric lighting, cold white, warm white, tunable white, LEDs, whatever you call that, and of course for any RGBW color mixing optics or applications. The question for you, I mean, as light designer, light developer, will be how to pick a combination in between LED cluster, and an optic that will reach your target or your customer's target in terms of color mixing consistency. Let's just go back for a while on how the human eye perceives the colors. So the visible spectrum goes from 380 nanometers to 780 nanometers. So it be in between red and violet. So before infrared and before ultraviolet. Our eyes actually have sensors called cones, which will react to three very distinct stimuli, X, Y, and Z. And all of the colors we can see with our eyes and brain are represented in what is called a two-dimensional color space. You can see here on the right, which is a representation, long story short, of all the colors we are capable to perceive and to distinguish. How do we distinguish color? What makes your eye, and what is the mechanism and phenomenon that will lead us to say, okay, this is exactly the same color, or the color is consistent, or I can see differences in the colors. So scientific approach has led to what is now called the Macadam ellipses. Here you get some examples of these black ellipses among the color spaces representing the Macadam ellipses. To get a very clear overview of what a Macadam ellipses represent in the real world, it means that all of the colors, all of the different color variations that will be within one ellipse, our human eye will not be able to distinguish any color variation or any color shift. So the Macadam ellipse is the space within the color space where we are not capable of distinguish any color shift. Here, the ellipses are plotted on what is called the CIE 1931 color space diagram. They are represented right now for, I would say, visibility improvements has been affected by the 10 times ratio, so they are way smaller than that in the real diagram. One of the problems the industry has been facing with this representation of the ellipses is that you can see they are not very consistent. They don't share the same size, they don't share the same shape. Some are rounder, some are more elliptical, so it was not the perfect way to represent the ellipses. So a new color space representation has been brought called the CIE 1976. Without getting into details, what we can see is that on the right part of the screen, when we then try to represent these Macadam ellipses, color spaces where we can see any difference into the CIE 1976 diagram, they are way more consistent in size and they are way more consistent in shape. In other words, they are more rounder. So nowadays, we will strongly recommend, and the industry has switched to the CIE 1976 diagram to deal with color shift and color consistency. So we had to build something. We wanted to measure the consistency of a beam. Could be a projected beam on the wall, or could be like a wall grazing application, or any indoor application you can figure out where the color consistency might be a question. So we want to qualify the color homogeny of a light beam using Macadam ellipsis steps. We had to name it, so the name is the color consistency index we contract into the CCI internally. The higher the CCI will be, the worse the color consistency will be, and the worse the result will be. Some examples here, picture taken from a LED manufacturer communication package. Because LEDs have been used, LED manufacturers have been using the Macadam ellipses for a while for binning/sorting of LEDs among production variations. So we see that two steps will be barely visible by the human eye. At 3 steps, I don't know how good your display and picture quality is, but we can start to see here, among here, that these two beams does not really produce exactly the same color. And within 4 steps, there is an obvious and clearly visible color shift in between this LED and this LED. And we can also see, by the way, that in that particular picture, the color consistency of the beam, this is a very simple reflector, basic stuff, which is not part of our product portfolio, by the way. We can also see that the color consistency is not very great. We have something more reddish in here. It's pretty yellow in here, becomes slightly pink on the edge. So even if here we have a color consistency difference in between two LEDs, we also have within the main beam some very visible color consistency issues, which could be possibly a problem for your application and customers. How do we do that CCI measurement and extraction? It's pretty simple. We use high resolution, very high sensitivity color camera. We spread the beam among the wall. We take a picture of this beam. So this is a representation of one of our collimators. This is how the image could look in a very simplified way and monochromatic way, by the way. And then we apply some math to that. Long story short, it's mostly standard deviation. There is, of course, some filtering in the process to get rid of the data that is not relevant. Could be the level of light, could be outside of the beam angle. I mean, the D10 beam angle, which we don't really consider for the CCI measurement. If you want some more details about how we proceed, I mean, technically speaking, about the math themselves, feel free to ask. It's not something we want to keep for ourselves. I think you understood that basically we developed that for our own internal research and development use, but we had great feedback from customers where we presented that, and they are now using that on an everyday basis for their development. So there is nothing we want to hide. There is no patent for Gaggione or anything like that on this measurement protocol. So we are ready and willing to share with anybody wanting to use it, understand it, or maybe challenge it. Some guidelines about how to interpret some results we're going to talk about later. We're going to always express the color consistency in numbers of steps of Macadam ellipses. So 1 step would be, I would say, perfect color mixing. Anything would be visible to the eye. When we are in between 2 to 4, depending on the application, the beam could be considered as good enough. We'll say it's hardly visible to the eye, then it's a matter of interpretation. It depends on the eye, it depends on the application, and it depends on how picky the final customer, the final decision maker will be regarding color mixing. And that's exactly the era where we were stuck without having a fair measurement, because from 2 to 4, results can look pretty similar to the eye, but technically speaking, they are not very similar. And if we go together above 5 ellipses, there would be a clearly visible color shift on the resulting beam. So just some guidelines. Perfect will be 1. Good enough for some market will be between 2 and 4. Usually 2 to 3 ellipses will match customer specification, but it depends. Sorry, my phone is ringing. How can you use this data What we do is that among our standard optics offer, we have a selection tool online on which there are many criteria you can pick from. I mean, form factor, material, RGBW, tunable white capability, UV capability, size of the optics. Anyhow, there are, I think, like 25 criteria you can play for to select your optics. We measure all of the LEDs we have with all of the optics, and we publish the corresponding measurements. So you will find very common measurement, FWHM, FWTM, sometimes two values when there is an elliptical optic involved. But we now on also publish the result in terms of color consistency index. So knowing what LED you want to use or your customer has been validating or willing to use and what type of application you're dealing with, you can already predict how good or how bad the color mixing will be. This example here I'm showing you is based on the E19A from Nishia cluster for tunable white made by our friends in Lumitronix. So it's a real world example where you can already figure out what would be the result of the so-called LLC25N from Gaggione using that particular LED. We publish that for all of the LEDs we have. This is not something we can simulate. You will find sometimes on our website some simulated data that will appear in blue. It's a matter of gaining some times given the rate by which the LED manufacturers are pushing out new products. But we strongly prefer measurements. We had some bad experiences and some disappointment. Let's state it as it is on customer side using only simulations. So simulations are great because they are fast. They are not very accurate, especially for very narrow beams and especially for color mixing, where there is at this point no real tool for color mixing consistency simulation. And gotta say that is something we are already working on. So what are these LSC25, whatever you don't know about? These are our latest generation of 32mm color mixing collimators. They come in various light distribution. And as I was telling you, we are quite of specialized into narrow beams and color mixing. So we usually release a bunch of narrow versions of the collimators. Here, as an example, all of these 32mm color mixing optics will be compatible and will provide great color mixing results and consistency with the Smart Array Q4 modules from Lumitronix. And we here have three different narrow beams. We have a proper narrow beam. We have a color beam, which is something the C you will find in many of our product range. Let's say it like that. Color beam is not necessarily the most narrow version of our collimators, but it's the best compromise we've been able to come out with, considering it has to be narrow, but still provide a good color mixing consistency. And in that range, we also have a dedicated version for wall grazing, which is the 25G, and then a medium, a wide, a very large, and an elliptical version. Pretty standard stuff. If there's anything you want to try with these, you can request Lumitronix. They have samples available, and if they don't have, I'm going to ship them to them, and you're going to be able to make a real opinion based on this possible combination. Another product range that might be relevant to discuss the color consistency index and color mixing topics in general is the latest generation 45mm color mixing. So it's, I would say, basically the same technology. It's a bit more, I was about to say it's just a form factor, shrinkage, or swell of the optics. The optical engineer will not be very happy about me telling that. But what I can tell you is all of these 45 and 32mm optics are based on the same concept, for which Gaggione has a patent on the color mixing technology side of the design. And we will find here quite the same logic. Here we have 5 different I would say narrow beams. Some are ultra narrow beams. They won't be the best one, of course, for the color mixing. They are more intended to serve application where the on-axis intensity is the key. So maybe not such of a deal for indoor lighting. It's more like searchlight application or very long range lighting markets we are serving with this. But for narrow beams, I would say proper narrow beams, we already have 3 versions. They will all provide different color mixing versus beam angles versus LED compatibility compromises. And we also have a LLC 59C for color beam versions. This LLC 59C has been maybe one of the most successful collimators from Gaggione's standard range. We launched this product, it was, I think, 2 years ago, and it's constantly ramping up in sales, and we constantly see new application for this product. We started with entertainment stage lighting. We are now fully into architectural application, and we see a lot of customers starting to use these optics for spot lighting indoor, could be shop lighting, could be office lighting. We also have some customers integrating these optics, I mean 32 or 45, into custom orders for linear application. We can also provide as custom parts for the market. And that's it for me today. Thank you very much for your time, and thanks again to Lumitronix to giving us the opportunity to present our technologies and products.